Good morning, dear friend. Let's see Science 1, topic number 4, measurement of matter. It includes काय काय मध्ये law of chemical combination, atom, shape, mass, valency, molecular mass, and the concept of mole and radicals. Okay, matter, we know that matter means in a previous standard, in last standard, you all already studied about the matter and their chemical combination or chemical reactions are the properties. Okay, Dalton's atomic theory you all studied, that is the important principles in a formation of a molecules of a compound. Okay, compounds are formed. How compounds form? When two or more elements combine together, then the compounds are formed, and the molecule of compound is formed. Okay, in a compound, see, we know that in compound two or more chemical substances are combined together. In a 18th and 19th century, scientists performed the experiment, and while they perform experiment, they measure accurately the substances used and form. Dalton, Thomson, Rutherford all studied the structure of substances and the atom, and then discovered that the chemical law of chemical combination. What they told in chemical combinations, they told that in a chemical combinations or some compound is formed by combination of elements. That means calcium chloride, it is formed by calcium and chlorine. It's formed by calcium and the chlorine. That means calcium and chlorine, it forms the CaCl2. This is known as a chemical combinations. When chemically they are combined, see the weight, these are known as the reactant, and this one is called as a product. If we take the mass or the weight of the reactant product, the reactants and the product total weight is remains constant. So this is known as the law of conservation of matter. Conservation of matter. What he told that in a chemical reaction, the total weight of what is there? Total weight of reactant is equal to total weight of product. Okay, this is known as a law of conservation of a matter. In 1974, French scientist J.L. Proust, he proposed the laws of constant proportion. Law of constant proportion. What is this law? He stated that the proportion by weight of constituent elements. Okay? The proportion by weight of constituent elements in various sample is constant. Means, also means, suppose in water, What is the constituent of water? Hydrogen and oxygen. So in water, the hydrogen and the oxygen proportion is 1:8. That means 1 in a 9 gram, that means in a 9 gram of water, 1 gram of hydrogen and 8 gram of oxygen is required. It is the constant everywhere in water. That proportion is a constant. Okay. Similarly, in a carbon dioxide, carbon is made up of the carbon and the oxygen. So in a 32 gram of in a 44 gram of carbon dioxide, the 12 gram of carbon and the 32 gram of oxygen is required. Okay, so the proportion is called as a 3:8, and here the proportion is called as a 1:8. Okay, so that is the constant proportion. That proportion is always constant in every substances. Okay, then the important is atom. What do you mean by atom? We should know that atom consists the center part, that is called as a nucleus, and in nucleus of atom, proton and neutron are present. Okay, and around the atom, the third particle is present. That third particle is revolving around the atom in a orbit that is called the electron. Okay, that is called as the electron. So atom consists proton, neutron and the electron, three particles. Okay, this proton and neutron present in the nucleus, proton and neutron togetherly, they are known as the nucleons. They are called as the nucleons. Okay, so the size of atom, we can determine the size of it. How can we determine the size? From the nucleus, the distance of orbit, this is known as the radius of orbit. It is called the radius of orbit. As the orbit increases, then distance also goes on increasing. So the size of atom determined by using the radius. Okay, atomic radius of an isolated atom. Atomic radius means distance between the nucleus to the last orbit, and this atomic radius is, it depends on atomic radius, and it is measured in a nanometer. That is the nm. It is the unit of the radius of atoms. Okay, uh, one nanometer means it is equal to the 1/10⁻⁹ meter. That means 1 into 10⁻⁻⁹ meter. Okay, and therefore the 1 meter is equal to 10⁹ nanometer. Hydrogen atoms, if we take the hydrogen, in a hydrogen atom radius is 10⁻⁻10 nanometer, or in meter, 10⁻10 meter. Then the water molecule radius is about 10⁻⁹ meter, and the hemoglobin molecule size is 10⁻⁸ meter. Okay, so the different size of the different molecules. But means it is a size. It shows the size. But what is the mass of an atom? Mass of an atom. See, atom consists proton, neutron and electron, right? Three particles. Proton and neutron present in nucleus, and electron around nucleus. Okay, in atom, the mass of electron is negligible, which is almost equal to 0. So in a mass of an atom, electron mass is not added. Okay, सो मास ऑफ ॲटम इज डिटरमाइंड बाय यूजिंग दी प्रोटॉन. इलेक्ट्रॉनचा मास फार कमी असतं त्यामुळे ते गृहीत धरलं जात नाही. मग मास ऑफ ॲटम ओनली प्रोटॉन अँड न्यूट्रॉन मास इज इन्क्लुडेड. दिस प्रोटॉन and neutron particles, these two particles are known as a nucleons, right? So mass is determined by using the proton and neutron. So mass of atom is nothing but it is a proton plus neutron. Okay, but in earlier days the mass of atom is detected by the concept, that is the relative mass of an atom. That concept was because that time in the 19th century there was no method to find out the accurate mass of an atom. So there they use the relative mass of an atom. That in this concept, the hydrogen mass of hydrogen scientists use as a one unit because it is the smallest, and so its mass is accepted as a one. Then the other element mass is compared with this hydrogen mass. That means nitrogen is 14 times larger than hydrogen, and therefore mass of nitrogen is 14. म्हणजे नायट्रोजनचं मास हायड्रोजनच्या मासपेक्षा 14 टाइम्स जास्त होतं, मोठं होतं, म्हणून त्याचं नायट्रोजनचं मास काय घेतलं जातं, 14. ओके, therefore this relative mass of nitrogen is 14, but the relative atomic mass of various elements were determined, and therefore on this scale the relative atomic masses of many elements, sometimes that many element atomic masses come to be in a fraction, mean in a point, and therefore the different atoms were, instead of hydrogen, the different atom was selected or choose. In 1961, then carbon atom was selected as a reference. The mass of carbon atom is 12. Okay, then by using the carbon atom mass, the hydrogen mass is calculated. How it is calculated? Because hydrogen mass is 1 upon 12 times less than carbon. Okay, and therefore hydrogen mass is equal to the 1. Then hydrogen mass is equal to the 1. In this way, the mass of an atom, mass means mass of one proton and one neutron on the scale of relative atomic mass is approximately 1. So here this is the mass of various substances given in your textbook. Hydrogen mass is 1, helium is 4, lithium 7, beryllium 9, boron 11, carbon 12, nitrogen 14. Oxygen was not detected that time, but now it was 16, fluorine 19, neon 20, sodium you have to find out 23, magnesium 24, aluminium you have to find out, silicon 28. So some elements mass is not given, that mass you have to find out by using the number of protons and the neutron present in the nucleus of that elements. Okay. In this way, the elements can be calculated, their masses can be calculated. Okay, while studying the chemistry, their chemical symbols are used. Chemical symbol means, what is chemical symbols? In last standard you are studied that chemical symbol. Chemical symbol means abbreviations of names of compound, of element. Means for that what they use, the first letter or first and second letter, or first and appropriate letter from the name, from their name. Okay, hydrogen, see, hydrogen. So name of hydrogen start with the H, so the symbol of hydrogen is H. But helium also start with the H, but already H is used for hydrogen, therefore symbol of helium is used as a He. Okay, in this way the first letters or first or second letter or first or appropriate letter can be used as a symbol. Every time this first letter always write capital, the first letter always write capital. For carbon, C, right? Then for cobalt, CO, C and O. Then for chlorine, there are the C and the small letter Cl. Okay, that are the symbols of the. But in earlier time, before that, the symbol of hydrogen, hydrogen symbol is used circle and the dot for the symbol of hydrogen. Then copper. Then for copper, they use the circle and C. Okay, that types of symbol are used. But later on, by IUPAC, by IUPAC method, these every symbols are given their chemical name or symbols. Every chemical is given as a symbol. International Union of Pure Applied Chemistry. International Union of Pure and Applied Chemistry. The name of it is a short form of the IUPC. Okay. Then next period we will see the molecular mass. Thank you so much.